Okay, good morning, everybody. I hope you sleep well. So many light from the projector. I'm Ghezzi Luigi. I'm technical marketing engineer for Hamamatsu Photonics Europe. And today my presentation will be a show basically what we can offer new from Hamamatsu. Okay, sorry, something. Okay, if you don't know Hamamatsu, Hamamatsu is a Japanese company. We are we have very long experience, 70 years more or less. Uh, we are worldwide leader in optoelectronic manufacturing components, emitters and detectors, but we offer also module, camera and complete optical systems. What I want to highlight in all the number that you see here, it's in particular the number of products that we can offer, 50,000, and two part of three of these products are customized. Our adding value is not only to support the customer in the implementation of the product, but also to provide customized solution for the different application that they need. As I mentioned, we can offer in particular photosensor and emitters as components. Basically today my presentation will cover the starting part, so up to the InGaAs sensors that we can offer. But as you can see, we have more detectors that cover also the mid-infrared range. My colleagues last year make a presentation on it, so I hope that you are more interested in the first part that it's the talk of today, but if you are interested in the second part, please write us and we can put in contact or provide you the presentation. So let's start from the UV-Tron. The UV-Tron are the sensor that we provide for the detection of ultraviolet wavelengths. As you can see here, basically the principle is very easy. So we have the classic photoelectric effect on the cathode of the metal. So from the UV light, we create the photoelectron that is basically multiplying in the gas that are present between the cathode and the anode by the what is called gas amplification effect. So basically the collision of this photoelectron with the molecule of the gas create secondary electrons that basically arrive to the anode. What I want to highlight about this sensor is the very high relative intensity between 200 and 300 nanometer. And for example, here I just compare the relative intensity of the sensor with some event that can be detected with this sensor. So in particular, the gas flame of hydrogen or the discharge for the high voltage systems. Why it's interesting this region? Because as you see, usually the spectra of the sunlight is very low in the ultraviolet region. So we can detect this also in the ambient light condition. We don't have the effect of the sun. What we can offer for this, we offer the UV-Tron, that is the detector that I show now. And we have different type of detectors, depends of the wavelength that you want to detect. But now we are developing also this module that is a plug and play module that basically can be assembled with different of our UV-Tron and can be connected directly to the system by link port here. It's a plug and play module. So you already have all the electronics and you can easily test how works the UV-Tron in the condition that you want to measure. So it's very good module to immediately test if the UV-Tron is the good choice for the detection that you need to make. Let's move now to the silicon part. As mentioned, we can offer different type of detectors from the photodiode to the APD or the SPED or the MPPC that are multi-pixel photon counting. It's our branding name. It's also usually called silicon photomultiplier. And exactly as you can see here, depends from how many light in your system is present, you can use the correct detector. So when we have a lot of light, usually we use photodiode. When decrease the intensity of the light, we go on APD or before PMT, now on the silicon-based MPPC and SPED. This because basically depends from the gain that this system have at the internal. So in the case of photodiode, we doesn't have any gain. So it means also that the signal is very slow. When we need to have low light and high speed signal, we need to increase the gain. And this happens with the APD. If it's not enough, we need to use the APD in Geiger mode. That basically it's the SPED. SPED, just to clarify, what why I use SPED, because SPED is the single photon avalanche photodiode, means that we have just one sensor between anode and cathode. When we collect more SPEDs, so we have a matrix of SPED connected to one anode and one cathode, we have an MPPC. That is the collection of many SPEDs. We can offer this type of sensor with many different packages, depends from what you need and which is the application. What we have new, in particular for the APD, we have basically, you know that APD, the gain of the APD depends from the temperature. And to obtain a constant temperature, basically you need to use an external circuit that check the temperature and adjust the voltage. Why this? Basically for the internal structure. When we have low temperature, basically the electron go inside the reticular without any collision. When we increase the temperature, the structure starts to have some vibration, and this means that there are a high possibility to have scattering of the electron inside the structure. So for this reason, we need to modify the voltage. What we are offering as new, we offer this new APD that in the chip already have a self-bias generator that keep constant the voltage, the gain. So you don't need to adjust the voltage. And this it's obtained in a very compact chip. You see it's a chip on board that it's around 2 millimeter, basically 1.8 and 2 millimeter. So thanks to this new product, you don't need to adjust the voltage for the temperature. It's automatically adjusted, and you don't need to add the external circuit for checking the temperature and adjust the voltage. You see here the behavior. On the left, you have the standard APD, so different gain at different temperature. And you see this new product that basically for each temperature have a constant gain. You see here. And this is the variation of the gain for the different temperatures. So you see that basically we are less than 5 gain in all the range temperature. We can offer this new sensor, but not only the sensor, we can offer also the sensor with the electronics for the readout. And we can offer also an array of the sensor, so 60 channel. These are the standard product, but as I mentioned, we usually are able to offer customized solution. Also in this case, we can offer different type of customization. For example, the array type, the active area, or the different gain that you want to use. These, for example, are 3 examples of different gain that we can provide with this new APD. This APD can be used usually for the industrial LiDAR. So all the applications need to detect distance in order to make activity like cobot or monitoring the box or automatic doors or for safety with the cobot when they are operating. But in the LiDAR, in the industrial LiDAR, we provide not only the APD but also other solutions. So if we consider a complete LiDAR system, basically we can provide all the key components of this. So we are able to provide the MEMS, the microelectronic mechanical system, the emitters, so the PLD, and the detector. For example, in this system, I will show you how works the MPPC that usually works for very low light, so long distance or very heavy condition. Depends a little bit for the application. The concept is very easy. Basically, the PLD emit the photons that reach the target and come back to the detector. the MEMS, we need the MEMS just to scan all the area when we don't want just one single point detection, but we want to scan the area. For sure, what the key parameters are the number of photons that are emitters, because more photons are emitted, more photons come back to the detector. As you can see here, depends from the distance, but we will see better this later. For the PLD at the moment, we are working in the, now we can offer the 3 stacks and the 4 stacks. Here the blue line, but we are already working on the 5 stacks. We are not just improving the output, but we are also working in particular on ratio between the energy and the output efficiency. So it means that we reach this high output without use more energy. And this is very important for the thermal stability of the system. For the MEMS, we can offer a complete range of MEMS at the moment. We have linear and 2D MEMS with the resonant or linear scanning mode. We offer not only these MEMS, but also the evaluation circuit to drive it or to test it easily. What I want to show you today, it's also the new MEMS mirror that we are developing, and soon in this month will be available. And in this case, we increase a lot the mirror size. We arrive to 5 millimeters. That is very high compared to the 2 that we have before. And the optical deflection angle is around 10 degrees with a frequency that arrives to 100 Hertz. So very good performance for this type of application. And this is native for 2 axes. So the advantage is that in one compact solution, you can cover directly 2 axes. Let's go to the MPPC. As I mentioned before, the MPPC is basically made by an array of SPAD. And here I want to show what happens when one photon is detected from one single SPAD. So very quickly, we have the photoelectric effect. So the electron-hole pair is created inside the detector. Thanks to the external driving, the external electric field, basically the electron go to the Geiger avalanche region where happen the photomultiplication, the electron multiplication, and the hole go in the opposite direction. And this basically happen for all the pairs that are created inside the detector. So basically you see here the signal, the voltage go inside the diode starting to go down, reach to the breakdown voltage, and the current increasing. What happens when the voltage arrives to the breakdown voltage? Basically, the detector stops to have the multiplication inside, so start just to have this discharge. This means that the current arrives to the top and now start to decreasing. And this is the discharge of the detector. So basically you see here what happened. The current go down and the voltage come back to the standard situation. This is what happened in one channel of the SPAD for 1 photon, and it's very, very fast. We speak about nanosecond, more or less. When we have more photons that arrive on the different channels, basically this is the signal that we reach. So the red one, you see, this is in the TOF system, usually what happens. You have the photons that arrive on the object that you want to detect, and if the object is very close, we collect many photons on the different channels of our MPPC, and this means that the peak is very high. When we have objects that are very, very far away from the detector, we have less photons that come back, and this means that basically the peak is not very high. In this example, it's comparable with the noise, background noise, that it's the black peak. And basically this event is cut off because it's under the threshold level. For this, it's very important to have PLD with high performance, but also MPPC or SPAD that have a high performance in the detection of the single photons. What we are offering as new in this field, we develop a new 1D silicon photomultiplier array or MPPC array that already is bonded on the ASIC, so we can offer some ASIC function. In particular, you see that we decrease the pixel pitch to 15, we increase the photon detection efficiency to 23, and we had some standard function that are the noise removal, the time of flight measurement, so it's already connected to the emitters and provide already the time of flight measurement. The energy measurement that basically provide information of how many photons we collect from the large of the pulse impact, and the detection that basically means that we are able to collect more events that are at different distance from one single pulse of the PLD. I show you that we offer all the silicon sensor. We can offer also the image sensor, so the standard CCD and CMOS. In particular, we are able to provide two types, basically, of image sensor. Depends if we are more interested in spectrometers or in the encoder, so industrial application, let me say. And in particular, for this field, we can offer these two types, so the large full well capacity and the distance sensor. What we have new, we have in the last year, we have some new products, so you see that now we are able to provide these CMOS that basically, compared to the previous version, to the past, now have a smooth behavior of quantum efficiency for all the wavelengths. In particular, this one are able to operate from 400. This one is particularly suggested for the near infrared because we increase the peak in the near infrared about 800 to 1000. And we are also able to provide this back illuminated CCD that are in particular for the ultraviolet detection, so between 200 and 400. Depends on the type of application that you want to use. What will be new release, it's this basically module that include our sensor. The first one is based on the sensor that it's already available. So this sensor that have 7 micron for 200 micron and 1000 pixel. But we are working on this new sensor that with the same dimension of the pixel have the double of pixel. And in this case, we are able to provide more readout, the double more or less, and also this 2 pixel binning function that basically make the sensor able to use the half of the pixel, so 1000 pixel, but with the double of the speed. So if you have application that require very high speed, we'll provide the sensor, but we are also working on this module. It's very draft, as you can see from the image here, that basically will be already with electronics to drive the sensor and will be easily connected by USB 3.2. I showed before that we have also this distance image sensor. Basically, these are sensors that are monolithic sensors that have inside the electronics and also the detection, and are very useful when you need to detect the distance from the center of the detector, because are very, very fast compared to the image sensor. We speak about picosecond in this case. We already provide this sensor. You see the first 2 lines are the sample that are already available, but next month we will also release the new one, 8mm with 1000 pixels, that basically have a frame rate of 800 frames per second, and it's SPI communication. So this is very helpful when you need to detect the position, because it's the reliability of this sensor are very high because it's monolithic and are very, very fast in the reply. Okay, let's move to the final part. Sorry if I run, but I have so many slides to show. We are able to provide also infrared sensor, InGaAs sensor, that basically cover all the infrared region up to the standard one. So basically, you see, this is the black line are the silicon, from the red one that basically it's from 1 micro to 1.5 micro up to 2.5 micro. We already provide this area sensor, but now we add to the family, this new family that cover all the spectrum, so from 1.7, this is the peak, to 2.6. Which are the advantage of this new family? We have more than the double of the signal noise ratio. We have the double of the dynamic range. We are able to provide the readout mode that integrates during the reading that thanks to this mode, basically we are able to catch out just few lines from the detector. So before we need to select an area and all the pixels inside the area give the output. Now we can select just few lines if we are interested in particular output of the detector. This means that basically we can have a faster detector for this. This detector can be used directly on the belt. This is the classic example. We also provide module to easily integrate this detector. Our module can integrate 3 of these detectors. In this way, you can have the extended wavelength range that you want to cover. But we also provide a camera, as I mentioned at the starting. So here, this is the new InGaAs camera that we are developing, and it's already available. You see that basically now we are able to provide a sensitivity range from 400 to 1700. It's easy connect with USB 3.1. We have the many image correction like background correction, shading correction, and defect pixel. And other main characteristics are the per-tier cooling and the frame rate and the very low noise that is present here, the exposure time. So this is the new camera that we developed and we add to our lineup of cameras. This camera covers the visible and the short infrared range. Okay, so we end the run of this morning. Thanks for listening. I hope that you have a lot of questions more than the time that we have. So in case if you want to see all the products that I showed this morning or you have more questions about it, you can visit us in this hall at booth 340. It's basically here, very close, on the other side, I think. So thank you for listening. I don't know if you have any particular question. You have a few time. Okay, so I give the floor to the next speaker. Thank you.